Hi, the title of our project is The Interactive Automata of an Oven. Now, before I demonstrate to you how the program works, it is important to understand what is a finite automata. Now, in order to understand what is a finite automata, we must first understand how machines work. Now, a machine is anything that assists human beings, assists mankind in simplifying certain tasks. And each machine is designed by its designer to fulfill a specific task. In the process of fulfilling the task, a machine undergoes a specific procedure, and each task requires its own independent and unique procedure as defined and designed by whoever designed the machine. Now, this can be said and illustrated in other words as the working of a machine from its initial state of being not used to its final state of achieving or accomplishing what it was meant to accomplish. It undergoes transitions through various intermediate states. That is, the functioning of a machine, the operation of any machine requires the transition of many intermediate states. And a state is nothing but a physical form. And as a machine moves from state to state, its physical form changes. Now, the state of a machine does not change on its own. It changes when a human operator or an individual desires to use the services offered by the machine. And so the individual who desires to use the services of the machine performs certain actions on the machine by giving inputs to the machine in a language that that specific machine accepts. Now, the language could be anything from providing a switchboard to providing buttons, or in case of a computer, providing a keyboard or a mouse. So machines accept actions from their operators, and upon receiving those actions, they transition from state to state and accomplish the desired objective that they were meant to accomplish. Now, in the case of an oven, we all know that an oven is used to heat or bake or cook items. And just like any other machine, an oven has many intermediate states that is brought about by the indulgence of actions on the part of a human operator. And now on your screen, as you can see, the top part of the screen is where the animation, the videos will be displayed. And we have taken small clips from an actual camera of the operation of an oven, and we have combined them using an interface, using buttons, and we have done so using Python and specifically tkinter, which enables programmers to provide a GUI, a graphical user interface based programming experience. So as you can see, the current state of the oven is Q0, and you can take reference to the ENFA diagram that is made here, and this diagram represents the finite automata, the set of states as enclosed by the circles. There are 6 states, and the arrows represent the actions that are performed to bring about a change in the states. So a collection of the states and the actions performed on them is what you call a finite automata. So this is where our oven is right now. It is off, its door is closed, and it is not heating. Now this is the default state of an oven. It is usually off. Now let us consider a specific case wherein the user, or let's say I, want to bake a cake. So I have prepared the, the batter, and now I want to use the services of the oven. So the first thing I do is to perform the action of switching on the oven, which is provided via the switchboard. So I switch on the oven. Now, as you can see, by switching on the oven, or in other words, by performing a certain action on the oven has now transitioned into another state, that is Q2, represented as Q2 in our ENFA diagram, and it did so by accepting the input symbol A, which is nothing but being switched on. Now, the state of our machine as of now is it is switched on, the door is closed, and it is not heating. Now, if you notice very closely, the set of valid actions on the state are now changed. Previously, we were able to switch on when it was off. We had an option to switch on, but now that it is on, switch on has been disabled. And now the only valid inputs are either you can switch it off, you can open the door, or you can set and start the oven. Now from this state, I am interested in keeping my tray, my mold, my cake, my uncooked cake inside the oven. And for that purpose, since my door is closed, I must open the door. So I click on open door. So this is the action that I desire to perform on this state. So as I perform the action of opening the door, it leads to the transition to the next state, that is state Q3, represented in our finite automata diagram, Q3. And we transitioned into Q3 via input symbol C, which is nothing but opening the door. Now the current state of our oven is on, the door is opened, and it is not heating. And again, the valid set of actions that we can perform on this state is different from the previous state. As you can notice very clearly, since I've opened the door, you no longer can set and start the oven, since most ovens require the user to close the door in order to begin operation. So at this point, the user places the tray inside the oven and proceeds to close the door. Upon closing the door, we revert to the previous state, that was Q2, which was on, door closed, and not heating. So by closing the door, which is represented by symbol D, we transitioned from state Q3 to state Q2. The only difference being that now our cake is inside the oven. Since we have closed the door, the action of setting and starting the oven is now valid. So in many conventional ovens, there is a choice provided to the user to choose between multiple temperatures, settings, times, directions of heat. So in our specific model, we have given the choice of temperature, the direction of heat, and the time of cooking. So let us, for example, choose 100 degrees Celsius bottom and 15 minutes and perform the action of setting and starting the timer. Now, as you can see, it has transitioned into the state heating, and you no longer can open the door. At this state, the timer is running. When the timer elapses, it moves on to its final state, that is Q5, over the input symbol timer elapsed. And although timer elapsed is not represented here, It is an input symbol within the circuitry of the oven and brings about a transition of states. Now, since the oven is now done, we have the option of opening the door. So at this point, since my cake is done cooking, I will open the door. Opening the door takes the cake from Q5 over an epsilon transition to Q2. We opened the door and went to Q3. And so now I take out the baked cake, and my operation of the oven, my um, usage of the oven has now come to an end. And so the user can transition from state to state depending on the kind of actions that are performed in each of those states. And no matter which action the user performs, the oven will only transition between these six states and can only accept these six input symbols. So the question is, why do we need to use a finite automata diagram? Why do we need to draw a finite state machine diagram? And the reason is that it gives us a bigger and better clarity on how machines truly work. It gives us a more efficient understanding, a more wholesome understanding of how machines can be made more efficient, more um, faster, and less time consuming in achieving their objectives. So I hope you liked our project. Thank you very much.